Good morning, welcome to
KidMath number 20.
KidMath number 20. So again, we're not going to do a problem today, but just talk about a little bit of history because it's sort of dawned on me over the weekend that before we jump into the next section studying quadratics, we should kind of understand why we're studying them and why it's important. So here's just a little bit of history. So there's a couple fundamental theorems, just basic ideas in math, and there's two I want to talk about today. One's called the Fundamental Theorem of Arithmetic, and that says for any integer there's a unique factorization into primes. Okay, so for example, I don't know, how about 60? How can you write 60 as a product of primes?
Well, I can write it as 2 times 2 times 3 times 5.
Okay, great. Perfect. Good job. And the Fundamental Theorem of Arithmetic says that no matter how you do this, you're always going to have 2 2's, 1 3, and 1 5. Now, you might write it as 5 times 3 times 2 times 2.
Yeah, but same thing.
But that's the same thing because of the commutative property and associative property. Okay?
Yes.
So that's what the Fundamental Theorem of Arithmetic is. And if this wasn't true, arithmetic would be impossibly complicated.
It would just fall apart.
Well, it would just be so hard because I would say, oh, the number 60, and you would say, oh, you mean 3 times 7? And I would say, no, I mean 81 times 6. And you would be like, how can those be the same? Okay, so if this wasn't true, this would be a big problem. And this was first figured out by Euclid, like 2,000 years ago, longer. I forget when Euclid was alive. And then Gauss. You ever heard of Gauss before?
Yeah, he's the dude who figured out 1 plus 2 plus...
Right, like when he was
99 plus 100.
Right, so when he was a young kid, he supposedly got challenged to figure out that, and he figured it out like, bam. Okay, so Gauss is sometimes, a lot of people think Gauss is the greatest mathematician who ever lived. And that brings us to the next problem, which is one of the things we're studying right now, the Fundamental Theorem of Algebra. And that says, if you take a polynomial, and we've been studying x squareds.
Yes.
It turns out to be true for anything, x to the n plus actually, I don't need to write it so abstractly, something like x cubed plus 3x squared plus 5x plus 7, that there's a unique factorization of this into x plus something, x plus something, x plus something. And it's unique, again, up to order. Okay?
Yes.
And this was first sort of conjectured by the, I believe, French mathematician D'Alembert, but then later proven again by Gauss. This one at, I think, age 21, this was actually his PhD thesis, proving that this was true. It's called the Fundamental Theorem of Algebra. And so one of the things we're studying, and actually you can see some of the pictures we had up, they're probably on screen, those are some quadratics about finding the roots of these equations. They're unique, up to order, and it was a bedrock theorem in math that you can do this. So that's one of the reasons why we're studying this. So about a little over 200 years ago, this was proven, that you can factor this in a unique way. And it's an amazing thing, and again, Gauss comes into play. There's one other theorem, fundamental theorem, and there's probably more. There's 3 that are important for sort of pre-college mathematics. It's called the Fundamental Theorem of Calculus. So we'll get to that.
We haven't studied calculus yet.
We'll get to that when we study calculus. Okay. Good job, sweetie. Good job this morning. And there's a little bit of history before we start the next chapter.